Namaste students, welcome back to my channel. Students, in our previous video, we have studied about the chlorine, that how we can prepare chlorine, what are the different physical and the chemical properties of the chlorine, and how chlorine is used for the preparation of the poisonous gases. Now, in this video, we will talk about hydrogen chloride, that is HCl. So, without any delay, let's get started. HCl, that is the hydrochloric acid. HCl, that is the hydrogen chloride, not hydrochloric acid, that is the hydrogen chloride. HCl was prepared by Glauber in 1684. Glauber in 1684 by reacting concentrated sulfuric acid with NaCl. So Glauber in 1684 prepared HCl by treating concentrated H2SO4 with NaCl, but its real nature was established by Davy in 1810. Have you remember this name? Davy in 1810, because Davy was the scientist who established the real nature of the chlorine also. So the real nature of HCl was established by Davy in 1810, and Davy showed that this HCl is made up of hydrogen and chlorine. So HCl was prepared by Glauber in 1684 by treating concentrated H2SO4 with NaCl, but its real nature and the components of HCl was established or shown by Davy in 1810. If we talk about the preparation of HCl, so HCl is prepared or HCl is manufactured by salt cake method. HCl was manufactured by salt cake method. Now, in this method, the concentrated H2SO4 is added to rock salt, that is NaCl. So, in salt cake method, the concentrated H2SO4 is added to the rock salt. The reaction between the concentrated H2SO4 and rock salt is endothermic in nature, and the reaction is performed in two different stages at different temperatures. At first stage, this NaCl reacts with H2SO4 at 420 Kelvin. At first stage, we keep the temperature 420 Kelvin. So this NaCl reacts with H2SO4 to form insoluble NaHSO4, which prevents the further reaction of H2SO4, on NaCl. So at this stage, at this temperature, the reaction becomes stopped. So at second stage, we heat the mixture at 823 Kelvin. And this NaHSO4 react with H2SO4. This NaHSO4 reacts with H2SO4, get converted into Na2SO4, and this NaCl get converted into HCl. So the reaction between concentrated H2SO4 and the rock salt is endothermic reaction and is performed at two different stages at different temperature. Why? Because in the first stage we get insoluble NaHSO4, which prevents the further reaction of H2SO4. So this reaction requires temperature of 420 Kelvin. So at this stage, we stop the reaction and then we heat the mixture to 823 Kelvin, as a result of which we get HCl, and a byproduct Na2SO4, and this byproduct is mostly used for paper making. This byproduct is used for paper making in paper industry. So salt cake method is due to the name of this method is salt cake due to the formation of the insoluble NaHSO4. This is our first method. Now, if we talk about the second method, very pure HCl. If we want very pure HCl, then very pure HCl is obtained by the direct reaction of H2 and Cl2. By the direct reaction of H2 and Cl2. So we get very pure HCl when H2 and Cl2 directly reacts with each other. Third, we get HCl. We get a large amount of HCl, but that HCl is in impure form, and we get that impure HCl as a byproduct from large organic industries. We get a large amount of impure HCl as a byproduct. We are not preparing HCl, but we are getting HCl as a byproduct from the large organic industries. For example, suppose if in an industry CH2 single bond CH2Cl, that is 1,2-dichloroethane. If we want to convert 1,2-dichloroethane into vinyl chloride, then we get a large amount of HCl. Though this HCl is present in the impure form, we have to pure this HCl. But we get a large amount of HCl through these methods, means as a byproduct from the large organic industries. Now, if we talk about the laboratory method, in laboratory method, the principle of the laboratory method is this one. But instead of NaCl, we used NH4Cl as a reagent. Means the principle of the laboratory method is this. But instead of NaCl, we will use NH4Cl. Now there is a question that NH4Cl is expensive than NaCl. So why we use NH4Cl? The reason is when NH4Cl reacts with H2, when this NH4Cl reacts with H2SO4, at first stage it forms NH4HSO4. But this NH4HSO4 is soluble. It is not insoluble. So it does not stop the reaction in the half stage. The reaction goes on because of the formation of the soluble NH4HSO4. It then again reacts with H2SO4 to form NaCl and Na2SO4 and HCl. So because of this, instead of NaCl, we use NH4Cl, though NH4Cl is expensive than that of the NaCl. But due to the formation of this soluble product, and here we get the insoluble product. So due to the formation of this soluble product, we use NH4Cl in the place of NaCl. So this is all about the preparation of the HCl. If we talk about the properties of the HCl, so if I talk about the physical properties of HCl, so HCl is a colorless pungent gas. It is a colorless pungent gas. And it is highly soluble in water. And its aqueous solution is known as hydrochloric acid. So HCl is hydrogen chloride. It is a colorless, pungent smelling liquid. But when it reacts with water, it becomes hydrochloric acid. Why it becomes hydrochloric acid, we will study in the chemical property. So these are the physical properties of the HCl. Now we will talk about the chemical properties of HCl. Now the first chemical property of HCl is its acidic nature. First chemical property is its acidic nature. ionizes in the water and behave as an acid. And through its Ka value, we also get to know that it is a very strong acid. It is a very strong acid. So when this HCl reacts with water, it forms H3O positive plus Cl negative. And through the Ka value, we get to know that it is a very strong acid. It is a very strong acid. And being acidic in nature, this HCl reacts with ammonia to form white dense fumes of NH4Cl. So because of being acidic in nature, this HCl reacts with the ammonia to form white dense fumes of NH4Cl. And being acidic in nature, this HCl reacts with the number of metals to form their respective chlorides, to form their corresponding chlorides. For example, Na reacts with HCl to form NaCl and liberate a gas, that is hydrogen gas, and with the pop sound we can prove that yes, this gas is the hydrogen gas. Similarly, Fe reacts with HCl to form FeCl3 plus H2. Mg reacts with HCl to forms MgCl2 plus HCl. So this HCl reacts with the number of the metals to form the corresponding chloride and liberate a gas, that is the hydrogen gas. Now the second property of the HCl, is it forms aquaresia with HNO3. When 3 part of HCl reacts with 1 part of HNO3, then the mixture is known as aquaresia. And this aquaresia is so strong that it can dissolve even the noble metals like gold and platinum. So what happened? In our previous video, we have studied this, that when HNO3 reacts with HCl, then it forms NOCl plus H2O plus Cl. Now this Cl reacts with the gold to form AuCl3, and this Cl reacts with the platinum to form PtCl4. And because in this we are taking excess of HCl, so this AuCl3 reacts with the excess of HCl to form soluble HAUCl4, that is orochloric acid, and this is the soluble part. In which we have gold. And similarly, this PtCl4 reacts with excess of HCl to form H2PtCl6, that is chloroplatinic acid. So in this way, HCl reacts with the ammonia. To form a solution, that is aquaresia, and this aquaresia is so strong that it can decompose, it can dissolve the noble metals like the gold and the platinum. This is the second chemical property of the HCl. Now the third chemical property of HCl is it on heating with the oxidizing agent prepare chlorine gas, which we have studied in our previous video. So what is the third property? Third property is it on heating with the oxidizing agent. It produces chlorine gas. So with oxidizing agent. So in our previous video also we have studied, so I'll write only 2 to 3 reaction. So when this HCl reacts with MnO2 on heating, to form MnCl2 plus H2O plus Cl2. Similarly, when this HCl reacts with ozone on heating, it forms H2O plus O2 plus Cl2, and this HCl on heating with CaOCl2 gives CaCl2 plus H2O plus Cl2. So with oxidizing agent, on heating with the oxidizing agent, these are the oxidizing agent. On heating with the oxidizing agent, it shows its reducing property. Here in these reactions, this HCl act as a reducing agent. This HCl act as a reducing agent. So it shows its reducing property and and reduce the oxidizing agent, and itself get converted into Cl2. Itself get converted into Cl2. So this is the third chemical property of the hydrochloric acid. Now the fourth chemical property. The fourth chemical property of the HCl is precipitation reaction. Precipitation reaction. The HCl reacts with the soluble salt of lead, silver and mercury to form the insoluble PPT. That's why it is a precipitation reaction. For example, AgNO3 when reacts with HCl form AgCl, which is white PPT, plus HNO3. This is white PPT. Similarly, PbNO3 whole twice. It reacts with HCl to form PbCl2 plus HNO3. This PbCl2 is again a white PPT. HgNO3 whole twice. This reacts with HCl to form Hg2Cl2, which is again a white PPT plus HNO3. So this HCl reacts with the soluble salt of silver, lead and mercury to form the insoluble precipitates of the silver, lead and mercury. That's why this shows a precipitation reaction. So these are the different chemical properties of HCl, that it is acidic in nature because it ionizes in the water, and from its Ka value we get to know that it is a very strong acid. Being acidic in nature, it reacts with NH3 to form white dense fumes of NH4Cl, and being acidic in nature, it reacts with the metal to form the corresponding chlorides and liberate a gas, that is the hydrogen gas. The second property we have studied, that it reacts with the salts. It reacts with the salts means it decomposes carbonates, and it decomposes carbonates, bicarbonates, sulfates. It did this also, means being acidic in nature, this HCl reacts with Na2CO3 to form NaCl plus H2O plus CO2. Being acidic in nature, this HCl reacts with Na2SO3 to form NaCl plus H2O plus SO2. And being acidic in nature, this HCl reacts with thiosulfates, that is Na2S2O3 to form NaCl plus H2O plus SO2 plus S. So these are the different chemical properties of the hydrochloric acid. Now we'll talk about some uses of HCl. HCl is used in tanning and sugar industries. It is used in the preparation of aquaresia. It is used in the preparation of dyeing. It is used in the dyeing process also. Next, it is HCl is used in the preparation of the chlorides, in the preparation of the metal chlorides, NH4Cl, chlorine, etc. It is used in extracting glue from bones. It is used in extracting glue from bones. It is used in medicine. as a laboratory reagent, as a laboratory reagent. So these are the different uses of HCl. It is used in tanning and sugar industry. It is used in the preparation of aqua regia. It is used in dyeing process. It is used in the preparation of the metal chlorides, ammonium chloride, and chlorine gas. It is used for extracting glue from the bones, and it is used in the medicine as a laboratory reagent. So in this video, we have studied all about HCl. That is how we can prepare HCl, why the method through which we prepare HCl is known as salt cake method, properties of HCl, and how HCl is useful in the preparation of the other compounds. So students, that's all for today. I'll see you in my next video with a new topic.